No? Top left says, in black she wrote Watershed Connections. Okay, so while Dr. Rathburn's speaking, this is what you should be thinking about. On the top left, what are your personal interests or personal connections to Watershed? In the top right, how does this connect to your content expertise or your licensure area? Okay, so we don't want you to think, oh, well, I'm math, this doesn't connect to it at all, right? Or I'm chemistry, that doesn't connect. Because I don't think we have any geoscience people in the room at the moment, but this is an area that does connect. Okay, so we'll be thinking about that. On the bottom left, it says social justice. You know, why might watershed issues be a social justice issue? And on the bottom right, it says place and location relevance.
That happens to me around here all the time.
Okay.
It took me a while to figure out gardens.
All right, so today I'm really super excited to invite our last speaker for this year for our professional development series for Noyce, which is called Sense of Place. And again, for those of you who are our new Noyce scholars, you now know that we're really interested in using place-based education to sort of guide our professional development series. And Dr. Rathburn, I met her when I first moved here. I moved here in 2008, and soon after I met you because I was teaching science methods, and you came and spoke to the class about Get Wet. Yeah, and we walked over behind the Hilton and looked at some of the sites, and then subsequent to that, we had a few other interactions where you were writing some proposals because, and Dr. Rathburn is in the geoscience department, but has an active, part of her role is, I don't know if you'd call yourself a discipline-based ed researcher but very committed to improving Earth system science education. That's her interest. And very well read in education literature and has published in like Journal of Geoscience Education. So she's interested in education issues. And then the last time I really chatted with you, my daughter came and interviewed you when she was in middle school and came and did it, and then took all these pictures. Shanti was very, very quiet, and now, and was very excited about becoming a geologist. She went to high school and didn't take geology. I know, right now she's
poorly represented in the high schools, I have to say.
I know, it's not, I feel really bad. I still think she would like geoscience, but she thinks that she likes physics and environmental science, so that's what she's, yeah, and I said, take a geology class when you're in college. I think it will bring it all together, because she says she's interested in how can we get enough water to people. That's what her interest is, and I said, I don't know about physics. You know, I'm not sure, maybe you need to study geology and environmental science, but that's, and I said, remember Dr. Rathburn? We just talked about, so she's headed, Shanti's actually headed to college in the fall. So I'm going to let Dr. Rathburn talk about it.
Thank you. Thank you. Well, I'm very excited to be in front of emerging STEM educators. That's very exciting. We always need good people to be in education promoting STEM because we all see that as a result of students who are well prepared to come on to CSU. So I should just preface a little bit of what Nina wrote. I was actually hired as more of an educator to promote geoscience education and some curriculum development at CSU. And that's since changed. I'm doing a lot more research, and when I was in that role, I was actually the master teacher for our college from 2008 to 2011. And so what I had to do was respond to faculty needs and try and make sure that I was addressing everything from how best to teach. You know, I had to introduce them to Bloom's, the taxonomy, and really what was sort of high-level teaching, to everything about just integrity issues. So I held workshops and I wrote weekly teaching tips and sent those out. And some people really responded, and others said, I really want to have time to do this, but I feel so busy. So now I'm one of those busy people and really want to have more time to do a bit more curriculum development and course content. So I still have a love for it, and I think about it because once you do it, you can't shed it. So I'm very much involved in incorporating my research, which is focused on fluvial geomorphology, which is the study of landforms that are shaped by water. And I incorporate that into my teaching. So I'm now fully out of the introductory geology courses. And so I'm teaching upper division, and I think that's great because we have new, young, energetic faculty who I think the students will really connect with. And so I'm helping try to mentor them. So as a fluvial geomorphologist, my current research interests are really in to the response to disturbances. I have a colleague who calls me a disturbed geomorphology. And so what I do is I study how drainage basins respond to fires, to floods, to mass movements, and those can be natural. And I also study how channels respond to anthropogenic events that deliver large quantities of sediment into drainage basins. So it's really a sediment pulse. What happens when that gets delivered to a channel? How does it propagate down? So we end up having, just as a result, important water quality issues and water quantity issues, okay? So what I'm going to do is I'm going to draw some places in the watershed. You know what our hometown watershed? On a small scale. What's our hometown watershed? What would you call it? What's the river that flows through town? Yeah, Pooter, the Cache the Pooter, okay? So it's really interesting because for us we see that, but in places that are more urban, sometimes students miss that they actually don't live in a watershed. But every single place is part of a watershed, okay? So ours is shaped kind of like that, and I'm going to make it a point here, okay? And the main stem, Cache the Pooter, flows through here, okay? Takes off. Okay. So if this is Fort Collins here, the river ends up flowing through town, and where does it go? What next bigger river would then it add to make a then bigger watershed? The watershed being the boundaries that drain water to a common area delineated by a channel network. Everyone know where this goes? It goes through Greeley.
The Platte.
It joins the South Platte and becomes part of the Platte. So we're actually part of the Platte, which is part of the Missouri, which is part of the Mississippi. So you could say we're actually within the Mississippi River drainage basin, but that doesn't bring a sense of place very much. So let's bring it back. This is a Cache the Pooter. This is the North Fork. You've been up to Gateway Natural Area. Okay, it's really truly in the canyon. This is the South Fork. And CSU's mountain campus is up here. And this happens to be what we call the main stem. Okay? And this heads up in Rocky Mountain National Park. So the boundaries of the park kind of cut through there. So we have a watershed that heads in really mountainous areas. It can be very wide glacial valleys because of glaciation that ended about 12,000 years ago. Could be very small flow that you would never imagine is our big raging river through town, because you can jump across it here, to a bedrock canyon. You've driven up the Cache the Pooter to coming out at Fort Collins. Okay? And this is where it emerges. So we have this mountain setting and we have this plain setting. My research is primarily in the mountain setting. And I think about disturbances like fires, okay, floods, and we've had plenty of these in the recent past, and mass movements. I think these two are self-explanatory. Fires, they can be wildfire, they can be human-caused. Floods due to big storms. Mass movements is an umbrella term for things like landslides and debris flows and mud flows. Okay? It's an unstable, usually steeper area of debris and rock, and it moves rapidly downstream. Okay? So we ended up having a fire in 2012, a flood in 2013, and as a result of both of those, we ended up having a lot of mass movements that delivered sediment into the river. So what I study is how much sediment comes out of drainage basins as a result of fires, floods, and mass movements. So fires, it's real important, and I'm slowly, where I was often more focused on the reach scale, a common length of river that has similar geometry, I now can't help but work at the watershed scale. Because what happens upstream is seen down here. Were any of you around? Yeah, Mike.
So I have a question. So
Yes.
if you think about Horsetooth Reservoir
Right.
and where that water comes from, what do you call it when humans have artificially transported water to a new area, I guess that kind of becomes part of the watershed as well?
It does.
In a way, so it's
It's
artificially,
It's called a diversion, okay, and what I really like to study is Q and QS. This is the discharge of water. This is the amount of water going through the river at any given time, and this is the amount of sediment. And these are the main drivers that are going to change channels and watersheds, okay, once the sediment gets to the rivers. Okay, so Mike's question is great. Turns out that we end up getting flow. Let's put, we'll put Spring Creek here. Okay, we're gonna do here's actually, let's do this. Let's put Horsetooth, okay? It's actually out on the plains a little bit, okay? And it's kind of north of town, okay? And then it turns out that there's pipes that bring Horsetooth water, okay, from the Colorado River Basin over the divide into Horsetooth. So that is called, it becomes part of what we then have to care about because it's additional water. And if it's released, it can entrain sediment. Okay? It's a lot of pipes though, so it's not a natural channel. But there's a lot of diversions. We have an intricate plumbing system going on in our hometown watershed. So you were down here looking at the Get Wet, okay? We happen to have, up at the North Fork, we have Gateway Natural Area, and that's where we put in wells and surface water gauges to monitor flow, and students go out and do this regularly. And then up at the South Fork, we're gonna have our mountain campus. And our dean just approved some funds to actually instrument the South Fork of the Cache-la-Poudre so we can collect data on an important tributary. We have some information coming from Gateway, and now we actually, and this is more groundwater at the Get Wet along Spring Creek. But we're starting to actually instrument the watershed where we can determine what's going on seasonally. This happens to be a really important source of water, drinking water for the city of Fort Collins. So we have a dual source. We get water from the Cache-la-Poudre and from Horsetooth Reservoir. You can imagine in the summer when the river gets really low, that's when we augment more with Horsetooth. In the winter, or in spring, they can pull more from the river because there's just more flow. And it comes up in spring when the snow melts and it drops down to low levels in August. Okay? So it's a dual source. That was an interesting fact that I collected some information from my students when I was doing more GSONS education. I wanted to know if they knew where the water supply came from. And of about 300 students, only 50% knew where we got our drinking water. So the sense of place was really not something that, and I even though we would teach all of this, I sometimes felt like there was just some fundamental getting out and seeing these and understanding some of the plumbing would have really helped the students. And only 15% could really illustrate what groundwater looked like. Because not only do we have all of this flowing in a river, and if we looked at a cross-section, okay, if we have this, we took a piece of river, part of the river here, and we chop it and we look at it in cross-section, and that triangle indicates the water surface, so it's flowing into the board. We know that the water surface in the river is a manifestation of the water table in the ground. So I do a lot of that also, groundwater, surface water interactions. How does fire change that? By removing vegetation. How do floods influence that? By causing this channel to be heavily eroded, right, and get much larger and removing a lot of vegetation. And then what do mass movements do is they bring lots of coarse material down into the river system. So as I start looking at larger watershed scale, I also have to take in the biotic influences, the vegetation and the fish and the macroinvertebrates. I'm particularly interested in sediment transport and hydraulics and how sediment moves through rivers, but I can't help but care about what vegetation does in stabilizing banks and when you lose that.
I'm gonna stop and can I ask a quick question?
Absolutely.
Because I wanted to check, for something, and I'm gonna ask you all. So how many of you are from Colorado? Okay, so that means the rest of you are all from not Colorado, right? Is anyone from this county? Did anyone grow up here? Okay, oh, that's right, she went to Fossil, that's right. So besides Carol Ann, do the rest of you know what your watershed is in the community where you grew up? So I just typed in, I just wanted to know because I thought I knew, I told you I was from Champaign County, Illinois, typed in watershed, and the EPA has a website that
Hometown Watershed.
will tell you
Yeah.
what the watershed, there are 5 watersheds, I did not know this. This county crosses 5 watersheds, my county has, I only knew about 1 of those. I feel like I just learned something. So I just wanted to, as she's talking, as Dr. Rathburn's talking, think about what is your hometown watershed, or what watershed sort of, cross or serve your county.
And another thing that I would add to what Mina is saying, which I think, because I was thinking along parallel lines to you, as Dr. Rathburn was like presenting this, I was thinking, whatever school you end up at, or whatever community you are at, maybe a good thing to do would be to use this as a model to think about, where does the water come from for this community that I'm teaching in? And what are some of the issues around that? And how would it tie into my curriculum? So I think that EPA side might actually be a
It's
model.
a really good one, but
Yeah.
yes,
Yeah,
that's
it
great.
says surf your watershed, so if
Yes,
you
Surf
Google
Your
surf your
Watershed,
watershed.
EPA Surf Your Watershed. Yep, that's a great one. Okay. I think you can type in hometown, yeah, okay.
And just to add to that too, if you're not teaching the high school and you're teaching the middle school, they don't know where anything comes from. They don't know where their food comes from, it comes from King Soopers. They don't know where their water comes from, it comes from the tap. They don't know where it goes. They don't know that there's a water treatment plant. They know nothing. And so when you start to talk about this, I taught in Thompson, so obviously we had the big Thompson flood. And that was a huge thing for us when we taught, and took kids out to see what came down the river after the flood. It was amazing. And they're still cleaning up. But they don't know anything. And then once you tap that, they're like, what do you mean my water that I flushed down the toilet today is what I'm drinking in a couple of weeks? And they're like, oh my gosh, I need to know where it came from and where it's going. And now you've got that hook to have them care about the watershed and to care about where their stuff comes from and what they need to do to help it.
Yeah, that's a really great point. And it turns out that, the fire that we had really affected the water quality. Turned out that there was a slurry of water that looked like it could have been coming out of some kind of a coal mine, coming down the river, and they had to shut off the water treatment plant. Actually shut off the intake in the canyon that brought it to the water treatment plant. So we were relying solely on horsetooth water that whole time. Turned out that it was a big factor for the breweries here in town because the water had a smoky smell. So people were complaining that the beer and the water don't taste right, smoky. So we were getting clean water because they shut that down, but there's a smoky smell. The odor of smoke is really hard to treat. And you can introduce some harsh chemicals to clean that up. It's fine in terms of water quality standards, but it's a little bit like you're drinking in front of a campfire. So likewise, with the flood, turns out I'm working in a neighboring watershed looking at the effects of the flood on their water supply reservoir. It's the city of Longmont and Lyons, and they have one reservoir that collects water from North St. Brian Creek. There was 500,000 cubic meters of sediment that was eroded. Over 50% of that ended up in their reservoir. So they would rather store water than sediment, so it decreased the storage capacity of the reservoir by 2% because of a 4-day storm. So really remarkable amounts of sediment. So understanding how these affect our water quantity and water quality, and then how rivers recover over time. Because you know that we had this 2012 fire, and then we had a 2013 flood. So we call those compound events. One ends up compounding the other. It turned out that that flood was one of the best results for cleaning up water quality. All of that rain over that September, those 4 days in September 2013, washed out the fine sediment that was in storage in the ash, and it cleaned up the watershed. Who would have thought that? That was a good thing, except for a lot of erosion and washed out roads and homes that were lost. And so understanding the processes, so I'd really like to emphasize that if we understand the processes that are going on of erosion and deposition and or the precipitation and what kind of mass movement, we can then go with the form it takes. The processes lead to the forms in the watershed. The slopes are steep because of bedrock, geology of course, but often because of sediment that gets shed down, okay, and shapes that landscape. Valleys are wide because glaciers move through, or if glaciers didn't, they're V-shaped and they're narrow. So being able to look at the landscape and interpret what are the processes acting on it to give it the form gives a really holistic sense of what's happening in a watershed. And I think kids, even middle school and high school, can kind of grasp that. They can look at what the form is, what is the shape, trying to interpret and back out, almost like some, you could call it sleuthing, identify the history of that basin. So I could go on some more, but I don't know if I should.
I'm gonna stop right here and we just heard all this amazing stuff and Mike is itching to ask questions. But before Mike asks any questions, I told you that he was a teacher, but I didn't tell you that he loves being a student. I'd like, what are some questions that we can ask Dr. Rathburn about, some of her research, but also just about watersheds. How might this be relevant to your content area? I want you to think outside the box here. What are some, are you thinking of thinking about connections? What are some questions that you can ask her to as you grapple with that?
I have a question, not even like talking about how I teach this, but I'm from Utah, so watersheds are huge.
Right.
And in my undergraduate, I did environmental science, and I studied partially aspen. And our hook with that is that aspen have a lot better snowpack than conifer stands. And so not only do you have biodiversity, but that's helping with our water, and that will ultimately go to reservoirs. So I was wondering with things like fires and affecting foliage, how does that affect snowpack and then?
Yeah, that's a great question. So a lot of things happen during fire when you remove the vegetation, and you also seal the soils a little bit. The soils actually get a little bit burnt. So runoff happens much quicker, and it picks up sediment very rapidly. So just a little rainstorm becomes a big event. Right? What comes back first usually are the aspen. At least they did up in the Cache la Poudre after the 2012 High Park fire. The aspen end up often being the first. Yes, they regenerate quickly. So what that means, but snowpack-wise, when it's still burned and it looks like toothpicks sticking up on the landscape, snowpack is very much reduced. It's not retained because there's no shading. So then maybe on a north-facing slope, a little bit, but certainly not south-facing slopes. So the regeneration can happen quickly, but it's nothing like getting this overstory that shades snowpack, that retains it throughout the year, and then delivers the water to our water supply. The other interesting thing that was noted is that rivers that were not, if you go hiking up in the Rockies or up in Utah, you notice that there's some streams that don't flow all the time. We call those intermittent or ephemeral. They'll flow when there's water available. Lots of intermittent streams are now flowing perennially because of the fire and the flood. No vegetation that sheds water through evapotranspiration, so it's coming out as base flood. It's coming out in the groundwater, so there's no vegetation that's taking it up. So we're losing that water, but yet it's coming out of storage over a long period of time. So there's kind of two. The snowpack's really important, and then the change in the intermittency of streams. That's a great question. So I didn't address any of the social justice, or I'm real interested in the environmental justice issues. And I know we're going to watch a video, but when I teach our introductory students, I take a whole unit and I talk about buying a house. And I talk about it because it's going to be the biggest outlay of money ever. Your biggest expenditure probably during your life. I want to make sure that students understand what it means when they buy a house in a floodplain, what it means when they buy a house or looking at a house underneath a hillside that's got big rocks over it. They buy a house in Fort Collins that has a bedrock geology that naturally contains radon. You buy a house in California where there's a seismic hazard, a very real earthquake hazard. Something that is so important, because I never want to hear a student that said, I bought this house in the floodplain and then it actually flooded. So I emphasize that whole idea of recurrence interval, and that it's a probability, okay? It's a probability, okay? Given that it's a chance from 0 to 1, like you have a wheel on a roulette wheel, okay, a ball on a roulette wheel, and that you want to know what's the chance of a 100-year flood coming. 1 in 100 means 1% in any given year. And I think this is a really big misconception. It was not well developed. If we could go back and do this, I think we would just figure out a better way. But it's so important because people think we have 100 years till the next flood, or we've got 100 years until the next earthquake.
I see.
It's a probability. It starts new every year. You get a 100-year event tomorrow, we could get one the next day. It starts over. Okay. So this is what's been hard about people who lived through the 1976 Big Thompson flood, the 1997 Spring Creek, and the 2012. And they say, we had 3 over 100-year events in 50 years. Yes, right? That can happen. You don't like, oh, I got 100 years, I'm gonna kick my heels up and just live on the floodplain. So that's what I try to do, because the other thing is that many times vulnerable communities are the most frequently exposed to pollution, to the noise of industrial, right, and just waste, landfills, and often poor zoning where they allow some of these communities to be built. And that's something that we're going to see occurred here in Fort Collins during the 1997 flood.
I was gonna say, when we bought our house here, realtors had to work hard, because we're like, we don't want a north-facing house because the snow will never melt. No, we don't need to be near that river because that's in the floodplain. No, we don't want to be at the base of that mountain because look, you can see the landslide that occurred at some point in time. And she's just like, oh my God, well, like, where can you live?
So
we need to live up on the Granite Mountain. So we bought up
We
the
moved
mountain.
here in 2008, went from Fargo Moorhead, which experienced that spring, so there's a Red River, there are 2 Red Rivers in the United States. There's a Red River in Texas, which flows south, and the Red River in North Dakota and Minnesota, which flows north into Lake Winnipeg. And we lived in the flood zone, and it completely flooded, and there was no school. All the middle schoolers were packing lunches, all the high schoolers were making sandbags, and there are 3 different colleges. The college students were all placing the sandbags all along the river. I mean, and so they got service learning credit because this happened for several weeks. I mean, they said, if you are over 12 years old, we need everybody out here helping. I mean, it was, again, middle schoolers making sandwiches, high schoolers actually filling up sandbags, and then the college students going and placing the sandbags. And the community then quickly realized, okay, how do we integrate more watershed science into our science classes so that we can help our students, feel prepared and understand this and not feel like we are victims in a sense.
That's right. Knowledge is power, absolutely.
Right.
Well, and I think too, we'll be in our house 11 years, but when we looked for our house, we also looked at the cost of water. So we were very, very conscious. So our subdivision has a retention pond in the middle. We get our water from the ditches. When the farmers release the water, it comes into the middle of our subdivision. We are on non-potable water for our lawns. So where I pay, I think with my HOA, I don't pay for water to water my lawn, but my girlfriend who lives like in Steeplechase in Windsor, because we're out on the plain a little bit, if we get a bad year, it's $400 a month for her to water her lawn. And you have to keep it green or the HOA gets, so now we're looking at, yeah,
So that's
it's really interesting when you get east of I-25, what it starts to look like out there on the plains as far as where do you live, where do you get your water, where does it come from? We don't get
Can you
ours-
afford it?
Can you afford it?
And who
Yeah.
lives in those places?
Because we don't get our water till the farmers release it,
Right.
and then it turns off when they don't need it, and so then what do you do in the meantime, you know, if you have to, like one year we didn't get it till almost the end of May, but we had to pay for our water to water our lawn, I was like, whoa, this is a lot of money. And now we're getting it early this year, because the farmers want it early, so when you get east of I-25, it's a little different scenario for the plains, but our kids come from there too, so, and we may teach out there.
So I want you all to think, I was going ahead, Amy, but I want you all to think about what are some connections, how can you connect this to your content area? So that's what we're gonna sort of stew on for a bit here. Go ahead.
I had a question on recurrence intervals.
Okay.
Because hot topic is climate change, and
Yeah.
so I've heard that those might be inaccurate because we're having higher probability of extreme weather events. Those could be skewed because the way we document incidences or impact, like economic impact, is changing. So I was wondering, as a researcher, do you see those increasing, and are those based solely on past events, or is that forecasting at all?
So these are mainly based on past events, and it can be the historical record, but also what we call the paleohydrologic record. So they'll many times take rivers, big important rivers, and they find that there's really old deposits from floods that are tucked up into little alcoves or protected areas. You can actually date those and do some modeling and determine what was the inundation level of those floods. So those can get added. Progressive communities will add that paleoflood record. Okay? What I see is a change in this, and much of it is related to what we call stationarity, and what we are now moving into is non-stationarity. You think about just the variability, okay, of storms. It used to be that we could envelope it, and we would expect the storms, that it would be really dry, it would be wet, we could see that variability, we could envelope it, where that is not the case. We don't have any bounds now that can really contain the variability, so it's what we say is non-stationarity. Floods are becoming more frequent, so a 100-year flood may truly be a 20-year flood. And this hit home for me after the 2013 flood, when I heard that the Colorado Department of Transportation was thinking about, instead of designing bridges, so we design all sorts of infrastructure, bridges and roads, and we map floodplains for a particular recurrence interval. A 100-year recurrence interval is sort of the design recurrence interval. CDOT was saying, we're going to actually build these bridges for the 30-year event rather than a 100-year, so they can actually break out. And these bridges won't be choke points in valleys where there's a lot of ponding, and then when they break, it actually is more destructive to the downstream area. So that was really interesting to me, and scientists have been talking about a lot of the climate change and the increase in variability, and that there's a government entity that's starting to plan for this. Let's just build the bridges so they can break out every time we have one of these big storms, which are getting more frequent. So kind of the science, but yet then the real world applied, people who are trying to provide the infrastructure.
I'm going to put on my teacher hat here
Yeah.
before we transition, because Dee Dee's going to have to plug in her computer to get our next piece ready. I'm going to ask this side of the room to turn and to ask somebody, because we've heard from this side of the room over here, well, from Amy onwards. So, but I want to hear the wonderful, amazing voices over here. So think about, what are some, do you have questions? Let's maybe we can all, let's explore and think about how might you teach watershed science in a math class? What are some ideas?
I come up with sheets of probability of flooding, but then also flow rates, and using different equations to model that, and then even geometry, different volume.
Yeah.
You could do a simple water budget in a river.
yeah.
That would be a great thing. They could take and look at, what's kind of just inflow and outflow. Okay, so you could say, we're gonna take what's, discharge in, okay, what else is coming in, right? Maybe plus or minus discharge of groundwater, right? That might be coming in. We could add precipitation, and then that's gonna equal discharge out plus evaporation. Yeah. So this is something that students actually can they have a little budget. It's like they have a bank account. The water that's coming in, the water that's coming out. And we lose it to evaporation to the atmosphere, and then it might rain on the river. But then the groundwater could be being contributed to the river, or it could be a gaining or a losing river. So yeah, I like that. Having them be just fluent with some of the terms and the manipulation, then it makes it really easy once they see some data. Oh, yeah, I get that.
And here's another opportunity where it's like, well, why am I learning some simple algebra?
Yes.
You know, here's a reason. It's not just something that lives in the land of A's and B's, you know?
Yes,
Right?
that's right. And we have symbols that really are very simple to understand particular parameters.
There's some other connections that you think you could make in your class. Oh, go ahead, Mike. Mike, no,
Well,
he's got.
I was just,
We're like over here talking about stuff that we
I
can't.
was wondering if the equity in the social justice, if, how does that fit in like with water law too?
That's a good
Because I remember
question.
that Nancy Kellogg, who had been kind of part of state efforts for public education, she had made this big game that kids would play, and by the time they were done playing that game, they had some sense of water law in Colorado, and it's really complex.
It's the same in California. I remember, I lived in California for 4 years, and I remember, hearing about and learning about the way that farmers, so this is, in the mid-'80s, small family farms were sort of dying, right? They were being replaced by these larger industrial farms and large-scale farms. And so what they would do is sort of play these games of having different addresses for the same farm on different parts of the land, saying, we can get this much water, we can get this much water, and they use different people's names. But if you look, it's simplified in my mind, but imagine a big square block, and it's just placing properties on different 4 parts of this block, and sort of saying, oh yeah, we're different farmers, and therefore, should be allotted this water. And it was really just because water is a scarce resource. And in years when there's not much snow and there's not much, water that can be used for farming, the people were playing, I don't mean to say playing games, but they were trying to work the system so that they could keep their, maintain the yield.
I'm not sure how it plays out social justice-wise. I mean, money drives water law. Except for we have some very old adjudications that they're senior water rights. Union Colony, Greeley was settled very early in this settlement of the area, and they established prior appropriation so that you're first in time, first in right. If you get here first, you can grab the water in a particular volume, even if it has to flow past people who are going thirsty. Right? Prior appropriation. If you don't use it, you also lose it. So you've got to use that up. So, class of mine, we looked at CSU spraying the green playing fields. It just looks like it's evaporating on a summer day. Well, it's a senior water right at CSU, and we had a facilities manager of the facilities come and talk, and he said, we have a very senior water right, and we're using it, or will you lose it? So CSU is trying also to use more non-potable water, low flush toilets, but they have a big water right, and it's old. So it's first in time, first in right, and if you lose it.
You don't want to lose it.
You don't
Right,
want to
you don't
lose it, exactly.
So how do other
So it's
states
a
do
good
it?
question, I'm not,
How do other states do that? They don't necessarily have that?
all of the West does. The East actually does not have that, and it's based on more on your use and your need.
Right.
Yeah.
And so what about the law, the rain barrel law? That was changed recently.
That was changed recently,
Yeah.
because they said everything that hits your roof in Fort Collins, as it comes down and goes up your gutter, it needs to go into the street, so it flows through the storm drains and down into the river, because that's already appropriated, it's already called for.
So it's not, just because it rains on your property does not mean you own the water. You cannot collect the water and then turn around and water your garden with that.
And people went up and, they said, wait, this is my house, and so they were allowing 1 rain barrel per house. So.
And that was just a few years ago.
I have yet to get one, I'm gonna get one
I know.
just because it's raining on my
I
house.
know.
Well, and I think.
Grab my
Greeley
water.
Doesn't Lake Loveland, if I'm not mistaken, is Greeley's water. The city of Greeley owns the water in Lake Loveland.
Yeah, and the city of
And
Greeley
so-
owns the reservoir up here on the North Fork. It's
Yeah.
called Seaman Reservoir. Yeah.
So all the $1 million
But if
homes
it-
in Lake Loveland didn't matter, it really
If it
takes
snows on your property, can you mine the mineral?
No,
You can.
the mineral rights are not yours.
No, I think this is a Western United States sort of thing.
Actually, I think the mineral rights are always separated from the surface rights everywhere
Yeah.
in the US.
Okay.
Yeah. So one thing I definitely wanted to talk about was your role as educators in getting students into natural resource careers. When I know that geoscience is not well represented in schools, and I also think that if students are interested in math and science, they're gonna go to the ones that really are, they're familiar to their parents and themselves, doctors, they'll become, maybe they'll go into physics, there'll be chemistry, physics, biology. So there's a lot of misunderstanding about natural resources, and I think it has come out, some of the research shows that it's the terms we use. I'm going into the field. Students in urban setting, that doesn't sound good to them. And if they don't understand that we really look forward to going into the field, because that means we're gonna be outside, there's a lot of, maybe parents don't know what it is to be an environmental scientist. They don't think that there's a real career in that. Can you make money on that? So whereas they would say, yeah, you can, you're gonna be a doctor, you're gonna be a chemist, you're gonna be a physicist. So I like to think about these issues that we haven't explored fully, social and environmental justice, a way to actually come full circle and have people help in their community is to get them in natural resources careers where they can recognize those injustices, and they can then go back to their communities and they've got knowledge and say, we're not gonna permit a landfill here. That's not okay. It's my neighbor. This is what it means to allow people to live on this floodplain. So what it means to alter the zoning codes to let people build homes here. So I know that a colleague in my college has done some work on this out at the Environmental Learning Center. It's through some informal education, and he's taken surveys, and it really is that often first-generation students, their parents don't know what natural resource careers are. So the importance of mentoring and some high-impact learning practices, getting students that have that interest teamed with a role model, a person who's doing that as a career. And I just like the thought of it ending that cycle, but bringing those people back into the careers, and then they can go into their communities and say, this is why we're not gonna allow this.
I'm really glad you brought that up, because I think that that is really important. You will discover in the schools, and maybe you already know this, many districts across the country, and Poudre School District is like this, based on your mathematics and where you are in math, they will encourage you to take certain science classes. So not all of Poudre School District, but some of the schools in Poudre School District, if you are doing, I don't want to say if you're ahead in math, but if you're just following the math sort of schedule, plan of schedule, you will not take an Earth System Science class. It is not required for you to graduate from the school district with an Earth System Science class. So therefore, my daughter, who was very, very involved in her middle school with Science Olympiad, and actually Mike's wife was her teacher. She said, this is what I'm gonna do, this is so amazing and interesting, and then we came and hung out in Dr. Rathburn's lab and talked to her. And then she went to high school and discovered that she didn't need to take it. She took biology, chemistry, physics, and now and now she could take an advanced class. So she decided, instead of environmental science, she decided to take an advanced physics class. So she never had any Earth System Science, and she said, I don't know if I know what geology is anymore, right? And so when she tells people, they say, well, why are you interested in saying you want to study physics and environmental science? She's like, well, and I was just telling you all that she's really interested in water, and how can people have water? And they'll say, I think you want to go into civil engineering. And she was like, no, I don't want to become an engineer. I want to understand things, and I want to work outside. And so, but she's like, Mom, I don't know if I know what geology is, because I didn't have it in high school. So, here's a chance to think about a topic that actually, I think as she's been speaking, we could all agree that it affects everyone's lives, right? Access to water. This is a right. It's like we all need water to live. But understanding our watershed and the access to water and some of the politics involved in managing water is one thing. but also understanding access to what information they have in their schools. Whether it's in math class, in Kendra's class, or if it's in you know, when Amy's teaching biology, how can we think about integrating watershed science into our classes? It may not seem intuitive initially. If none of you here think you're gonna be, we might think, oh, okay, well, that's something that the earth system science teacher should teach. But the last time some of your students may have had it would have been in middle school.
Well, and something that you'll all probably have to teach is at some point in some of the classes that you are in charge of will be the water cycle. So you could say, well, what does the water cycle look like in our community? And that would be a way to get at the watershed too.
That's, yeah. So before we take a break and then watch this film, go ahead.
One last thing too, is that when we first got into this career, the earth and space sciences were a dumping ground for kids who weren't, quotes, good in science. So basically what you would do is you teach physics, chemistry, or life sciences, and earth and space sciences were for kids who weren't good in science. And so it was just kind of like this dumping ground. But then with the advent of standards, that all changed. So then the earth and space sciences were integrated into existing courses. But the only problem is that the majority of people who become teachers, probably 80%, have a biological science background. So they may have never had a course in geology or meteorology or astronomy, and yet they're being asked to teach those subjects. And you know, we experience that ourselves. And so I think that's another challenge that all of you will experience. And that's why I like being a good student, because to be a good teacher, you have to be a good student. And especially in public education, where you are going to be asked to teach outside of your subject area for sure.
And to model for your students, right? If you're modeling for your students, I mean, Mike is part of this because he's a mentor for all of you, and we're going to do a little mentoring activity here when we watch this video and talk about social justice in a second. And, you know, Mike is modeling for you, and Lynn are modeling for you how they want to learn more information. And so we are going to challenge you all when you go and become teachers to model for your students what it's like to be a good learner, a lifelong learner. Nobody knows everything, and things are changing, and as things, you know, like in the city of Fargo-Moorhead, right? I mean, that flood really shook up the city, and they said, we know we're in a flood zone. How can we make sure that we really integrate this into our curriculum so that that our students understand this? They lived it for, you know, for weeks. They were not in school. How can we make sure that we turn this into something, opportunity for us to learn? So think about how can you integrate this? Can you collaborate with other teachers and do something, you know, maybe Erin works with Bree and you're teaching at the same school. How can you get math and science to be, you know, how can you collaborate if you don't know? How can you make sure that your science curriculum coordinator, or your math curriculum coordinator, like Dee, you know, was, when some of the teachers will say, we need resources on this. Can you come in and help us? We don't know anything. Where do we get our water from? We don't know this. The kids are asking. We don't know this. Yeah, Lynn.
The other piece too is if you decide to go to the middle school, it happens more often. But right now, some school districts are still earth sciences in 6th grade, life sciences in 7th grade, physical sciences in 8th grade, and never shall the others meet. You know, it's just like, this is my little niche and I'm not going out of it. But the other piece too with middle school that's so exciting is get a hold of your social studies teacher. They're probably teaching someplace in the world that might not be your watershed, but you might look at what does water look like in another part of the world. And then you get into this social justice thing. Why don't we have enough water? Where is that political, war, social, cultural piece of water? And then it ties to food. And then you've got kids that really like to eat, so then you have this. So if you can do those interdisciplinary things, then you've got, you know, one project with 4 different grades with math, and we can talk about that another day, but they've got 4 grades with one project. And they're seeing how it's all connected together, and we're reading and writing about it, well, that's language arts. And then we do this math thing, well, that's math. And then we have social studies, and it's all connected, especially in the middle school, and that's my passion area, so is that interdisciplinary work that we should be doing. Because it's not isolated, it's not in one spot.
Right, and so the social studies standards are broken up into 5 areas. You probably are familiar with your own content area, but social studies is broken up into 5 areas, and one of them is geography. And so geography standards actually overlap quite a bit with the science standards. And science standards are broken up into life, physical, and earth system science. I don't remember the math ones off the top of my head. Does anyone remember what the big areas are for mathematics? Yeah, the state standards, the big areas.
Yeah, number
Yeah, number
sense,
sense.
computation.
Yeah, that sounds right. So, think about how you can work with one another. I mean, on that note, I'm just thinking, I remember getting up in the morning at 3 o'clock with my grandmother in India. This is in Bangalore, which is now an IT capital of much of the world, I'm gonna say that. And she would get up at 3 o'clock in the morning because she had my grandparents had water for 1 hour. So their time in their neighborhood was from 3 to 4, actually about 3:15 to 4:15. We would get up and we would all fill the water from all the taps in these huge tubs, and that was the water that we had for the day. Right? And I didn't think anything, and people didn't take showers or baths. I mean, the amount of water that we waste here. So when you take a bath, even now when you go into some of the villages, you have a bucket and you have a little cup. And has anyone traveled to India or South Asia? And you have a cup and you pour water on yourself. And then when you're shampooing or soaping, there's no water running, right? It's just the water that you use when you need to rinse yourself off. And so the idea of when traveling back and forth between India and the US, I realized, oh my God, we waste a lot of water.
And what if the kids had to do that for a day? And they had to keep track of it mathematically about how much water they actually used for a day. And then they had to live like somebody else in another country? Oh my gosh. Think about it if you only had that, and they had experienced that.
Yeah, all the water and then all the.
Yeah, you wouldn't be able to flush
Yeah,
the
the water.
toilet. That would
Yeah.
be like way bad, but, I mean, it's giving those kids those experiences that they probably will never go to India, but what is it like to live someplace else? What is it like to not have that?
Yeah, there's a lot of places in the world where they don't have as much water as we use flushing the toilet one time.
I know, right. So if we think about these things, did you want to share something? Two of you were thinking about, you're making connections about how to teach about watersheds?
Well, that's kind of like where I grew up. I grew up in Vietnam for like
Okay.
10 years, so like water resource was limited as well, so.
Right, and so we take water for granted. You come here, and I remember teaching a class, I taught biology for a class of refugees in Fargo-Moorhead. Fargo-Moorhead at the time had the 4th highest refugee per capita in the country. Minneapolis, I think, had the 3rd. It was just very active Catholic social services and Lutheran social services that would sponsor UN refugees. And in this class, we were doing something about ecological footprint, and their bottom line was, oh, if you have a high footprint, that means you have a better life, because that means that you have enough to eat, you have enough water to drink, you have enough land or space to live in. And what we try to teach our students here is that we use too many resources. How can we decrease? And so it was interesting for me. I had to change my complete lesson. I realized I was coming in with a very middle-class Eurocentric view and teaching a very different population of students. And I said, you're right. On their exam, they wrote, a high eco-footprint means that I have a full belly. I mean, this is what they were writing. This is a good thing. The goal is to have a high footprint, to use a lot of resources, because that means that then I have a full belly, I have enough clothes, enough place to live. Now how can I, right? So I said, oh, you're right. How do we compare that with what's happening in the United States? It turned out to be a really, okay, we're gonna take a break because I think you've been sitting for a while, and we are gonna ask Dr. Rathburn if she wants to stay for 10 minutes, but they're gonna get up and move around and stretch. And then
We're gonna have Mike and Lynn introduce themselves.
we're gonna have Mike and Lynn, so just take a couple of minutes, move around, because we're gonna get this plug in a computer, and they're gonna introduce themselves, and Dee Dee's gonna introduce herself as though she is Alex, because we have the inventors, remember? And Alex is taking his dog to the vet, so she's gonna pretend like she's Alex for the day, but then she'll revert quickly at the end of the hour when her pumpkin will turn back into Lynn, or back into Dee Dee.
Turn back into
My kid. My old kid wants to know what's going on.
I know.
Sounds like
But you also have a real water, you're the one that can, like, when it's like wood, and you
Yeah, it's funny because as,
These are the
for years, like everyone else, kind of like business. And then when I started to really get a better handle on geology, I mean, because it's better than anything else.
Come get some food, eat the cookies. There's lots of,
I agree.
other
So
cookies or napkins or whatever they're there.
You should see the look.
When did you contact Ted? I was actually, I was actually acting English tutor for refugee services in Illinois and Wisconsin. And most of my students were. All right, love you. And the reason that is that they were women and children that really got that classes in English, but they didn't really understand who they didn't. So I would go into their whole things. So all of me, so I did that for 3 years. And they felt like I was doing it for volunteer. They were like, no, you don't need cherries, so you can feed you. That's okay. So I have a lot of food.
Did you travel to
I lived in Madison.
Oh, cool.
I did my master's at University of Wisconsin.
My sister went to like Waters.
Oh, okay, yes. Okay. So you're just, is this yours? Yeah, this is it. So the sound. Oh, if we do it in here, we will have sound. We just do the, do you press it? Right, let's see if I You know, there used to be speakers here. I know, that's what we worked on. Okay, why is the... This side, it's not. Maybe I turned it off.
There are 11 people. I like it, yeah. I really, so he's, hey, look, who just texted me.
When I tried
It was last weekend. Was it?
Well, we didn't have our Thursday. Or maybe this is the stuff. Yes. Okay, so what did you just do? I think I just. Oh. Okay, so where's the, I see this.
Subdivision.
Shocker. Shocker. Do you have any?
Oh, hi. I have not. I do, sometimes I go with my grandkids on capsule.
Do they have enough volunteers?
On Saturday we did, but we can always use more for the, you know, the national anthem that will be here.
When is
I should be able to tell you off the top of my head, and I can't, and I don't know why, I'm sorry. Yeah.
I know I ran home from teaching, jumped in and fed the dogs, and my son just called, please, Papa, I'm getting the yard basket.
Do you have
I got home.
well, there's sort of but there's a lot.
Just that you read it.
But were you the one doing it?
So we're trying something new. Dee has not her computer, but then we realized that we need speakers for this. So we're trying it on their computer, which is slow. And so that's
That's
what
pretty
she's,
unique.
yeah. So when I used to teach in here, I had speakers because I was shooting video, so I just brought in speakers and I just left them in here. But,
So in the rooms, like the first room we were in, when I
yeah,
was teaching,
when I taught that.
when I talked with
Yes.
Amy? Amy, right? No, not Amy. Oh God, what was her name?
Well, let's see, if not, then we could, but actually, then we have
I work here. Yeah, so did I?
Yeah.
I told you.
It will, yeah.
So, I work here. I'm on
Right,
the
I
student
know.
hourly. I work, kind of like I'll come in tomorrow.
I know,
And
I know.
I work on those young kids. I do some teaching. But it amounts to just hours. It's not a lot.
That's now.
It's fun.
Oh, yeah.
Oh, yeah.
You're available on here.
Yeah.
Okay, so do you want that, or do you want it all the way off? We fall asleep, so I'll show you.
Oh, yeah.
But actually, let's do our introductions and then
Oh.
sit and watch with your mentor.
Oh, okay.
Okay. Okay, so what we want to do is, we've had our mentors coming this year, but they've just kind of sat on the side and chatted with you a little bit. Our hope is that they can be more involved with you, and so that when you have questions, you can go to them. Also, when they see cool things and what they're doing, they can share those with you. And so we didn't want to say like, oh, you have to have this person as a mentor, and you have to have that person as a mentor. We want you to be able to hear a little bit from our mentors, and you can say, oh, I think this person would fit with my style really well, and this person would fit with my style really well. So I've asked them to be able to talk just real shortly about like what they have done within education, and then what they think their mentoring style will be. And then what we'll do is I'll have them kind of separate to opposite sides. And then
You're gonna be Alex.
and I'm gonna be Alex, and so I'll be back there. And then kind of when we watch the video, go watch the video with your mentor, and then we're gonna have some questions for discussion for you to talk about with that person. Right?
So again, they're gonna introduce what they taught, and their, maybe describe their teaching style. I'm gonna look at you too, just so you remember, I think Dee emailed you this. So your teaching style, and then what are your, maybe 2 or 3 points about what you think is important about mentoring. You wanna go, Mike?
I guess.
I knew, I was gonna say, are you gonna say ladies first and then I have
Actually,
to go?
Lynn and I have worked together
Yep.
before on some projects, and it was actually when standards were becoming, so important that our districts were having to like redesign classes and stuff, and so we were involved in. It was a grant through Hewlett-Packard and through NAS2,
Yeah,
National
NAS2.
Association of Science Teachers.
For what, 3 summers? 2
Oh,
summers,
yeah,
3
it
summers?
was pretty cool. So I've visited your classroom, and it's like totally awesome, and I would like choose you as my mentor in a second.
Mike has a great classroom.
I really would choose her as my mentor in a second. But anyway,
Thank
my
you.
name's Mike, and I taught for 30 years in Poudre School District, and I taught mostly junior high and a little bit of high school, and then I ended my career as a middle school science teacher. And so most of what I taught was high school level courses that were like introductory, like biology and chemistry, physics, to 9th graders. But I also would teach 8th graders. So then, and then I taught at the high school for a little bit. But then when we went to a middle school, I had to choose. And a lot of my colleagues were going to high school, And it was a really tough choice for me, because I think, content-wise, I kind of wanted to go to the high school. But as far as the people that I liked working with, they were all staying at the middle school. And I'm just like, and I liked 8th graders, and there weren't enough people in the school who did, so. I loved 8th graders. So I stayed, and I think it was, well, you know what, I think it was really good for me. I think I became a lot better teacher, teaching at the middle school. And I learned how to collaborate with other teachers, and it was really, really great for me. So anyway, I think I think it's great to have a mentor because it's nice to be collaborative and get multiple ideas on how to do something or how to approach a topic. And so I've had a lot of student teachers during my career, and my approach was always that I would learn from them and they would learn from me, and it was a real collaborative approach. So I don't know. I didn't read the email that told me the different things that I was
They
going to
didn't
do.
do their homework, but
No,
they like to be
I
students.
did. I read emails, but I just don't remember that
understand
these
that
were.
either.
So
That's okay.
let's see, introduce myself.
And what are some points, what do you think is important for a mentor, a relationship with them? So one is that you're learning from one another.
Yeah, and so, I guess I'm really approachable, and I'm, easy to talk to. I'm a good listener, and I have a lot of experience at multiple levels. I was a science coordinator for a while as well, and, I have 30 years under my belt that I think is worthwhile. As far as the relationship, the mentor relationship, though, I think I never want to, have a person be like a copy of me. I want them to be their own person and to figure out their own style. So towards the end of my career, I had some opportunities to have 2 student teachers at the same time, because CSU wanted to experiment with this and see what this would be like. And it was really interesting because, you had me, and then you had these 2 people, and sometimes they were very different in the way they wanted to approach the classes that they were in charge of. And I think that the important thing to know is that there's a lot of different ways up the mountain, and there have been, I've known teachers that are super excellent teachers, and I could never be them, and I could never teach like them. But I was good too. I just had different style. So I would not try to impose my style on you, but I would let you know what my style is. But I would respect that you might have a different style. So I like to try to nurture a person in a way that honors kind of their style and what they're comfortable with and what they like to do, because you can teach in any school and see that there's all different kinds of styles that are effective. So
Thanks.
I guess.
Yeah. Lynn.
I'm different, it's my way of the highway. No, I'm
The highway.
I did not start in education. I was a dental hygienist for 20 years. And my passion was always teaching, but my dad made me get a job where I would be able to support myself in the time that I was in college. So I did dental hygiene, I loved it. I taught at the university. I was an instructor, volunteer instructor for a while in dental hygiene. And then I went back to school and I had 3 kids, a husband and 3 dogs. So it was a little different. But I taught in Loveland. I chose middle school. I didn't know, I was like my kind of, do I do middle school or do I do high school? And I went to the high school and spent a day with one of the teachers, and I went to middle school and spent a day with one of the best teachers, I think, ever, and just sat there and went, this is where I'm supposed to be. I felt at home. And then my career just kind of went on from there. I am very passionate about interdisciplinary teaching, and I had some great people along the way who did weird stuff with me, like put 500 kids in the gym and have a science day where they teach each other. The big kids, we brought up the elementary kids from the 5th grade, our feeder schools, and our 7th graders taught. And then they came back and said, your job is really hard. And I said, yes, you will behave tomorrow, won't you? So that's really my passion, is interdisciplinary. How are those connections made? Where can we make them? And that will hook kids in. if you don't make it relevant for kids, it won't matter to them. It's like, why do I have to learn this? That's my piece of always trying to get that out. I've done research with Mina, which was very interesting in the connection between science and literacy. What, 5 years?
And social studies.
And social
All
studies
mixed
and
together.
math.
Yeah.
So we did that maybe 5 years, I think.
Focusing on limiting resources and,
Yep,
and
and then
food.
I'm also one of those people who likes to learn, and when she asked me to do this, I jumped at the chance. She's made me do a lot of things in my career, like write for publication, which was very scary for me, but I did it and it turned out rather well. I like to get kids out of the classroom. The more I get them out, the better it is, whether it's the Denver Zoo, the Denver Museum, or just out in the schoolyard, trying to figure something out there.
Or at King Soopers, she took her kids on field trips to the grocery store to learn about where their food came from.
Where does your food come from? So we went to King Soopers, and they actually interviewed the people that work at the store, and so that real life connection for me is really important. If you can make it worth their while to learn it, they'll remember it. We did a plant festival thing, and one of the girls one day was at the coffee shop at Starbucks by the school, and I remembered the face but not the name, and she goes, "Oh, do you still do that plant festival thing?" I said, "Yeah." She goes, "I eat lentils all the time and I didn't even know what they were." And I'm like, wow, you know, they learned it from the project. I'm the project queen. I was the project queen at my school too. I love hands-on learning for kids. The more you get them into labs and doing those kinds of things and making something, or, you know, the art part is really important to me too. So anyways, that was middle school. Taught mostly biological science, life science. Then we went into having to teach, earth science, which is not one of my fortes, but I had to learn it, and I was maybe a week ahead of the kids. I had no background in it. I didn't take any of it in college. Chemistry and physics I did with my background. Now my passion is elementary science, which is a big stretch, and I'm learning like every day that you have to make the lines bigger because they write really big when you're having them do observations. But I teach 3 days a month in Milliken. My friend is a principal. She wanted more science for her elementary kids, so I do K-5 3 days a month, and I get to do anything I want, and it's fun, fabulous.
I'm sure she would love volunteers to come help her.
Yes, anytime. We have a lot of UNC students there, and we're looking at how do we get you guys to, even though most of you probably won't teach elementary science, but you may end up in a non-traditional science role at a science museum. That may be your job.
Even if you do, you teach middle school and high school. I required, for the 14 times that I taught methods, all my students were required as a service learning project to partner with an elementary teacher and teach science or math at the elementary level. Required, and then they were not allowed to use any words that had more than 2 syllables. And I said, I want you to teach the standards. You're going to be teaching about electricity. If you're teaching about electricity, then you can use that word. That's it. And then I was like, and they learned so much. That was their favorite part of the methods class, was learning about how to talk about, without getting caught up in the college words. How do you teach things at an elementary level? So you can learn a lot. So talk to Lynn if you want to.
I'm still learning. No.
So what are your mentoring?
My mentoring,
philosophy?
no, it's not my way or the highway. It's hardly that. When I had tons of student teachers like Mike, and they would always say, you know, what do you? I expect them to work as hard as I do because it's hard work. This is not easy. I'm pretty easygoing. I love just sitting and talking and bouncing off ideas, and then I get really excited, and then my mentee gets really excited, and then I say, well, yeah, we play I love devil's advocate. How are you going to make this work? Because I think when you talk that way, you start to figure out the problems, but then you come up with the solutions. And anything you can do ahead of time, that's my style, is trying to map it all out. I'm a very organized person, except my desk. But other than that, I have a passion for it. After doing hygiene, I knew this is what I wanted to do, and I knew this is where I needed to be. And I actually do still substitute teach. I know that's not a good word, but
Neither of them are really retired.
No, we won't ever retire. But yeah, I think it's that piece of that give and take. I think it's that piece of getting excited and seeing the light bulbs go on and helping me. I mean, you may have ideas for me that I am still teaching and still know how to do and help me because, like I said, elementary science is like a whole nother ballgame. So I just like to have fun.
I had so much fun teaching elementary science. Oh my gosh.
You're gonna give them a thank you present.
Yes. So we have thank you gifts for
Oh,
both of you.
thank you.
Oh, wow.
That you can take home
Ooh,
and share
That
or
looks
not, or
simply
just like
delicious.
hide on your own.
So Dee Dee's going to be Alex and to describe the reason we're having them describe, but she's not gonna eat his chocolate bar.
No,
I
didn't even bring it here.
Oh, I know, she was like, this is dangerous, she thinks this is Alex's chocolate bar, I'm gonna eat it. So she's gonna, was he able to text you back?
No.
Oh, he wasn't, okay. So she texted him at the vet to ask him, what's your philosophy about mentoring? But we know a little bit, and I think, and Laura and I can try to jump in and share some things. So what's gonna happen is we're gonna divide up among the three mentors. Does that make sense? So you're gonna pick a mentor, go ahead.
Yeah. So Alex is still currently teaching. Teaches high school technology and some mathematics. So if anyone has ever heard of geometry and construction, that is one of Alex's passions that he teaches and has done a lot with that.
And algebra and automotive science, I don't know what automobiles and algebra, something like that.
So his passion is really that applied mathematics piece.
Well,
I don't even know what else to say.
He's a Noyce alum, and so I know that one of the things that Alex has said that he really appreciated about the Noyce program is being able to get to know people that are part of the community. So I think he feels very strongly that there is not, similar to what we just heard Mike saying, that there's no one way to teach, but that it's really about finding resources and then having a chance to actually try them on your own and see if it works, and then having somebody to bounce ideas off of. I know that that's what he likes about Noyce. I don't know other than that what his mentoring experiences are, but if you would like somebody whose background is in mathematics and who's in high school, then he would be a really a good mentor. He normally would, I think he'll be available, it's just this dog is not well at the moment.
And you don't have to stick with someone who teaches the same content area
Right.
as you. You can learn a lot from people from different content areas and how those function.
The
So
program at Loveland High, my kids went through, well, 2 out of 3 went through Loveland High. And that program where they apply everything they're learning. So again, it's that hands-on piece that makes kids say, oh, I have to learn algebra because I may want to build something someday. I think Mike is really into that kind of thing where he wants to make sure that it has an application to
Or
it.
Alex, yeah. So for the sake of time, I'm gonna ask Lynn if you can move over to that end of the room.
Yep.
Mike will stay there, Dee Dee's gonna stay here. I'm gonna ask people to get up and move to a mentor.
Divide yourselves up.
And then what we're gonna do is I'm gonna show this short film, and which is a film about the 1997 flood in Fort Collins. And the task with your mentor, the small group, is to discuss how might you integrate some issues of social justice, which are not explicit in the film, but implied, okay? And so your goal is to think about, as teachers, how might